let's look at putting together a test fixture for testing ballasts, particularly dimming ballasts. Here we have a shop light. It is model number 1233. It says shop light right on it, and it is from Lithonia Lighting. And what you're going to need to do this is initially screwdriver to take it apart, perhaps some needle noses to grab a little nut or loosen it. Then you're going to need to cut the tombstone wiring and eventually a wire strippers. Plus you'll need a marker to mark the top of the ballast or the Luminaire case. Now, as luck would have it, and it is luck, I purchased these T12 shop lights for $11, and the T8 shop lights were more expensive, and I didn't know what kind of ballast we had in these things. But this is beautiful because it's got an actual full-fledged program start ballast. We have these two connectors on long wires. We got these two connectors on shorter wires. They all have a hitch in their giddy up so I can extend them a little, and so I can literally take this wiring up through the top of holes we're going to drill here and here. We have a KTEB-240-1-TP/E Keystone ballast here, and it's a real one. And I got to tell you, I bought two wraparound fixtures, right, with that wraparound lens from two different manufacturers, and they've had instant start ballasts. So this was a really good deal because we can reuse these connectors and wiring for our test ballast. Now, alright, let's look at what we have here. We have the reflector removed, ballast removed. This had a screw and a lock nut on one end. The other end slides into these. We'll be abandoning those. Don't need those. And power wire left with these crimp-ons because I'm going to bring these well insulated wires up through a hole. Look at the lead length we have on these connectors, and none of them are shunted. They all have two wires on them. This is perfect for us because we are going to be drilling two holes here, well, probably about here-ish, and two holes here and a hole here to bring the power up through. And we're going to make every connection on the top of the ballast. Now I'm going to take like a gazillion different ballasts I have here and put them on the back side. I'm doing a second one as well, and finding all the places I need to match up holes. Yep, there you go. That one's different. This one's instant start. It actually only has two wires that connect to the tubes. The tubes on the other end are shunted together. They're hooked together. This is the one I'm interested in putting in right now, Phillips Advance. Here's a, I guess that's probably a T12 ballast as well. Here's a Lutron Ecosystem, and believe it or not, it has a different footprint than the Luminergy and the original Ecosystem. So let's take a marking pen and mark our main hole. They're all going to go to this one. Try and get it in the middle. And we make our little U shape there. And we know the screw hole goes something like there. And we do this other end. And then we can take any old ballast and lay it down on our first hole and find a place to drill and tap a number 6 hole out further. So far we have 2 1, 2, 3, 4, 5 opposite end holes to this. I'm going to drill it and tap at number 6. So you're going to use a drilling and tapping kit number 632, and don't forget to use some cutting oil when you are drilling in metal, no matter how thin it is. Once you have the appropriately sized holes drilled, go ahead and put a tapping tool in your drill, but do not forget to oil the tapping tool. Otherwise, your tapping tool will not last long. Remember, if your drill does not have a reverse on it, putting a tapping tool in it isn't going to work. Now we want to deburr the holes we just drilled and tapped. So just take a big old drill bit and reach in and give it a couple of twists to get these little burrs off. See these little metal flakes? Remove all the metal flakes and fragments by wiping them out with a damp paper towel and then turning the thing upside down and burping it. Now the reason I was trying to score the paint is because we want a good connection between the body of the ballast and the lamp shell. Because look at where the ground wires are attached. They're attached to the shell. Now more than ever, it's probably important to keep the ballast case grounded. So you're going to want to use some pan head screws and some toothed lock washers to break through the paint. Okay, we're going to drill our big holes for our pairs of wires to go through, and I'm going to use a 5/16 inch armored cable bushing to take these pairs through. We're going to cut the little tab off and reduce the length of the bushing a little. Now we're going to stick these into the holes to keep these wires that are on these ends from grating against the sharp side of a hole. Okay, 17/64 turned out to be a little small, so I arrived on 21/64 because I have that bit. I would recommend hot glue for installing these bushings in these large holes, but to tell you the truth, I can't find my hot glue stuff. So I'm going to use something called plastic weld epoxy. Okay, well, I had to use some 5-minute epoxy on the inside of these bushings to get them in place because the plastic weld didn't work so good. You can take the 2 wires from each of the tombstones together, because what's going to be in between these 2 wires is the cathode voltage, which is rarely going to exceed 10 volts AC or DC, but between these there might be high voltage, so you have to keep them separated while you are playing with the thing. Well, the number 6 screw holes were actually a bad call. You should use 8 or 1032 or even 1024, because it's a little hard to get this big fat notch that you find on a lot of these fastened down. So just grab some washers and hope for the best. And in this case, the best is 1, the ballast isn't going to come loose, and 2, that the ballast case is grounded to the Luminaire housing. So here's the screw where the ground wire attaches, and I'm on 2K ohms on my meter, and here is a little spot of paint I scratched off, and there we go. We have a short between the ballast case and the Luminaire housing, and that's what we want for a fluorescent ballast for sure, particularly an electronic one. Now when it comes to stripping and attaching the ballast leads to the tombstone or the lamp connector leads, we no longer worry about what color they actually are,
but refer to the diagram that's on the ballast to ensure we're hooking it up, because frankly I've got two brown wires here and you don't typically see that. Electricity doesn't care what color the insulation of the wires are, and right now you don't either. Now that we've followed the wiring diagram, we have everything wire nutted together, and we've left the 0 to 10 volt control lines open. And for older viewers, you're going to end up with something that kind of looks like Phyllis Diller's hair. Younger folks might not get that reference. We are very carefully inserting the bulbs, paying attention to the little index mark. And now we fire it up. Make sure both bulbs look fine and let it warm up for testing. And our initial test for the thing is to take the violet and gray wire and short them together, and that is as low as that Luminaire is ever going to go. And you see it has a slow fade down rate, something you might want to take into account. Open, as high as it's ever going to go. 10 volt control lines shorted, it goes down. Now you're thinking, why is this happening? There's no voltage on these. Yeah, there is. There's 10 volts and it's coming from the ballast. That's how 0 to 10 volt lighting rigs work. There's a constant current source in the ballast that's putting 10 volts here, and you put a varying resistance across it to determine where you've set the dimming. Okay, so we're going to analyze all the 0 to 10 volt commands and what you get out of Luminaires under YouTube videos that start out checking space 0-10V, 0 to 10 volts, no spaces, space control, space range, space 0-1 for ballasts, and then whatever ballast we're checking, this number will be incremented. 0-2 is going to be LED drivers. 0-3 is going to be phase control converters, like dimmers, right? Phase control dimmers. You can convert 0 to 10 volt to phase control. And then we might have an O for digital, conversion to digital signals. So this is what you're going to want to punch in to find all our analysis of all of these things.